So what is binary instrumentation? So binary instrumentation is essentially a method to get more information about an executable at runtime. So for example, it will give you information on the instruction that has been executed, how many instructions were executed at a given point in time. It allows you also to edit or manipulate code at runtime. So essentially it's a very broad topic. In this video the focus is more specifically on reverse engineering. So why is it so important? It's important because it can allow you, for example, to build exploitation tools where you search in an automatic way for specific vulnerabilities. For example, it could be that you're interested in searching for a buffer overflow or stack overflow vulnerabilities, and binary instrumentation can help you in understanding the program more, but also in automatically finding code paths which might trigger that specific vulnerability. Another way to misuse, you could say, binary instrumentation is to use it to bypass software verification techniques. So you could, for example, write a keygen which can activate Microsoft Office, or you could generate a serial based on the code that you have analyzed. So so it can be used by for a lot of different things. Some examples of binary instrumentation tools are Valgrind. So Valgrind runs on Linux. There is Pin2 from Intel. It can run on Linux, Mac OS X and Windows. It is under active development, and it is a quite advanced API. I've used it myself for a long time. I'm still using it. It's quite a good API, I could say. And then there is also Dynamo Rayo, which runs under Windows. So in this example, we will be looking at the Intel binary instrumentation framework. So we have the Intel tool itself, which will analyze the executable. We have the executable, which will be analyzed. And then we also have the script that will use the Intel binary instrumentation tool. So for this example, we have created itrace.c++, so it's written in C++. And what the script essentially will do, it will, after each instruction has been executed, it will try to write this instruction to a file named etrace.out. So let's look at an example. So we are in the directory of the Pintel binary instrumentation framework. We give it as parameter, so the pin.exe, with as parameter the etrace.c++, where we will record all the instructions, and then as a second parameter we give the executable we want to analyze, and we will also give that executable also a parameter. So if you execute it, nothing significantly has happened, but we can see that the etrace.out now contains all the instructions of the program that we just have executed.